So this is lesson 15, practice number 1, if you also needed help with that one. It says to select all of the quadratic expressions in vertex form. So let's see who's starting to memorize it. Table 4, can you tell me what the formula is for vertex form? Yeah, try to do it from memory. It was what we did yesterday.
Y equals A across something parentheses x minus 8 squared plus 10.
Okay, good. So that, when it's in vertex form, I can easily identify my vertex. So is the first option on my screen in vertex form? Does it look kind of like the format I have? No. Sure. I mean, it doesn't have the y equals, but can I tell my vertex? So then this one is in vertex form because I can tell from it that my vertex is going to be 2, 1. All right, so also remember HK is your vertex. H is always opposite sign of what it is in the equation. K always matches. So first one's in vertex form. Is the second one in vertex form? So actually it is, because I can tell my vertex from it. Since there's nothing in parentheses with the x, I know my h is going to be 0. And since this is a constant added or subtracted, I know that my k is -4. It is also in standard form too, but since I can tell my vertex from it, it's also vertex form. All right, now the next one. Do we see 2 x's in our vertex form?
Oh, no.
So this one's not. You know what form this one is? Well, we would distribute, but this is our factor form. So in vertex form, you should be able to see either an x squared or the parentheses squared. You shouldn't see more than 1x when it's in vertex form. So there's that, don't take that one. Is the fourth one on my screen vertex form? Yes, for that one, I can tell my vertex is -3, 0. So I would pick that one. Is this one, you're asking me if this one's in vertex form? This one. This one? This one? Yeah, I would. So is the last one in vertex form? Yes. So, and those had to be all the ones you picked. The only one you shouldn't have picked was the one that's in factor form. So questions on that one? Questions on others?
Number 2 on the same one.
On the 15 factor? Okay. So number 2 on the lesson 15 practice, we have 2 different equations. We're trying to figure out which one would be easier to use to find the vertex. What do you guys think? Yes, because that one's in vertex form, and by definition, it's also in the name. When it's in vertex form, you can see your vertex really clearly. So what is the vertex for this one?
-3 and
Positive or negative? 9? -9. So H is always opposite, K is always the same. So -3, -9. Which one would be easier to find the x-intercepts?
oh, and
Because it's in factor form. In factor form, you can tell the x-intercepts within a few seconds probably. And the way that you actually identify those x-intercepts is by setting each factor equal to 0 and solving. That's going to be a question on your test, so I need to make sure you know that's why it's usually really easy to identify the zeros, the x-intercepts. So what are my x-intercepts going to be? 0, 0, 6. Good. because you have to make basically each factor 0. So this one, if I make it 0, would make the problem equal 0. This one, subtracting 6 on each side would solve for the x on this one. So it could be either one. Okay, questions on this problem? Joel? Yes. Other questions on this one? So on the 15 practice, number 7. So we have 4 graphs and we're matching them with the quadratic equation that represents it. So let's just take a look at what we have going on here. Something going to the right, something going to the left, something flipped, and something shifted down. And comparing them all to my parent graph. So when we did the lesson, we always started with y equals x squared, our most basic one. And we did a bunch of different transformations to them. So I'm gonna start with what I think would be easier, which is the only one that is reflected. What causes it to reflect? Yeah, make sure you answer my question. What causes it to reflect? A negative or positive what? So when the A, the number in front of the x squared, is negative, is what causes it to reflect. So there's A in standard form, there's also A in vertex form, they both have the same effect. It's just an A, like A is that is the letters. So A is for the number in front of the x squared. When it's negative, it reflects. So which one has a negative x squared or a negative A? This one. So that one goes with graph C then, because it's the only one that opens downward, so that would be the easiest to tell. The first two shift either left or right, which is the same letter being changed, so I'm gonna go to graph B now, where it's moving down. You could. Okay. So Tiana asked about this one. So I'm gonna go with it. So which of these equations would give me a transformation where it's going down? You have 3 options. Okay, what would happen? So, well, let's look at our equations. We have a factored form here. In factored form, what's really easy to see? Anyone else can chime in too. In factored form, what's really easy to identify? Okay, so I know for this equation, what are my x-intercepts gonna be? Okay, good. Does graph 3 or graph D go through those 2 points on the x? So then you're not gonna pick that one for this one. This one's in standard form or vertex form. You can technically tell both from it. In standard form, you can tell the y-intercept is the constant. Does this one have a y-intercept of -3? Yes. So I'm gonna pick that one for this. That's another way you can go about it. And then this last one is also in factor form. So what are my zeros for this one? So then when we compare it to my given, let's start with the one with the zeros at -1, -3. Which graph has zeros at -1, -3? A or B? I disagree. Cause look at it. It touches -1, -3. So then process of elimination, this one must go with the first one, graph A. That has zeros at 1 and 3. Make sense? Yeah. Other questions?
Right.
Carly, did you have a question? Okay. I have time for one more, depending on how long it is. Question 1 of the study guide. All right, because that's what you guys should be focusing on too. That will be your main focus tomorrow, is I'm gonna give you the hour to work on your study guide. So, number 1 on the study guide. Everett is making a concrete path, X feet wide around a rectangular fish pond that measures 6 by 12. Which one represents the total area of the path and the fish pond? So the fish pond is, well, here. It's one big rectangle that we want the area of. So this dimension, we need to come up with an expression for, and then same with like the width, we need an expression for that. So this I know is 6 plus X plus another X, because it's like the same measurement. And you can simplify that, 6 plus X is what? Close, that would be multiplying, just adding the, what's X plus X? 2X is what it is. So this can be written as 6 plus 2X. And now for the width, I know it's 12 plus X, if we go this way, plus another X for this distance. And then when you rewrite that, it becomes, and then area of a rectangle, how do you find area of a rectangle? So I'm taking my expression for the length and timesing it by my expression for the width. Well, I am recording, but well, this would explain not the narrative. But moving on, from here, how do you multiply 2 binomials? Double distribute, FOIL, box method, whatever you like. Which one do you like? FOILing. So multiplying the first term with 6 times 12. $72. Then the outer term, 6 times 2x. Good. Inner terms, 2x times 12. And my last terms, 2x times 2x. Okay, and then combine like terms in the middle, however, I already know which one's my answer, because only one of them has a 4x squared. And when I do combine my middle terms, I do get 33. So that's what we're doing. Good, questions on that one? Okay. Well, if you're not gonna be here tomorrow, make sure you get your study guide done.